Here in geometry, we're going to be talking a lot through the course of the year about shapes, logic, and critical thinking. When it comes to geometry, first unit I like to cover is construction. So basically we are creating shapes using ruler and compass and all the definitions that go along with it. One of the first things I cover is here with points, lines, and planes. We've seen points and lines in algebra, on graphs, planes. We're going to go over planes. It's not the plane that flies in the air, but rather a plane as in a geometric figure. So definition-wise, we have a whole bunch of terms here that we've seen before in the past. We have a point. Basically, it's a location that has neither shape nor size, and we use a little dot, essentially, to say, hey, we have a point here, and we always label points with different letters. So we've seen point A, point B, point C, point D, all on the graph, point X. So point P would be a symbol or diagram for a point. A line is made up of points with no width, exactly one line through any 2 points. So we have here basically something that goes off straight forever and ever in both directions. And it says one line through any 2 points, so I can place 2 points anywhere on the line. Point A, point B, so there's a line. Symbol, what you'll see symbolized in some questions is the points that we run through. So in this case, it's points A and B. And then you draw a little symbol like that above it. So a short line above the letters A and B. A plane is a flat surface made up of points that extend infinitely in all directions, exactly one plane through any 3 points. And you'll see usually it's a parallelogram like that. A plane is essentially a flat surface. If you think of the floor being flat, you could say the floor is kind of a plane, or the kitchen countertop, or the desktop. And usually they signify it with a little italic letter in the corner. P is a very popular letter to use for plane. Collinear, points on the same line. So if we use the same example up above, we have a line here with 2 points on the line, A and B. A and B are collinear because they're on the same line. Coplanar, points in the same plane. So again, if I use the same example, so here we have plane P. If I got a couple points in here someplace, point A, point B, point A and point B are coplanar. Intersection. We're used to intersections on the road. Roads cross each other. So an intersection is where 2 or more geometric figures intersect. So let's say we have 2 lines here. So let's say we have 2 different lines. We got this line. And we have another line here. Where the 2 lines cross, that is our point of intersection. So right here, dead center, point T. So there's the intersection. A line segment is a measurable part of a line consisting of 2 endpoints and all points in between. So basically, we're chopping off the arrows on a line. So a line segment, it's still straight, but it has a set end. It has a start and a finish. So point A, point B. Just like up above with a line, we use the endpoints A, B, and we put a line up above it. Well, this time around, we're just going to put the segment part above it. So again, line. We made a little line above AB. Here we just made it segment AB. And array. Array is part of a line with an endpoint, and it extends away from the endpoint. So basically half of a line. So we start off, we have set endpoint A, we have point B somewhere on the line, and it continues off in that direction forever and ever. So just like a line, arrows at both ends, we have arrows on the notation, line segment, we have endpoints, so there's no arrows on the notation. And if I want to note ray AB here, it would be our letters AB with the symbol of a ray up above it. A figure, basically, it's a set of points in a plane. Figures, triangles, squares, rectangles, etc. So any shape could be a figure. A geometric construction, it's instructions for drawing points, lines, circles, etc. within a specific plane. Typically, we use a pencil, compass, and a ruler for it. And then the length of a segment is the distance from one point to another. So we can note it as AB. Inside, they're not really parentheses, but AB inside that, or just AB. And we could also use the symbol of distance A comma B. That tells me I got to figure out how far from A to B. Here we can use this following figure to name each of the following. So we need a line containing point W. Here we see point W right there. So I just need 2 points, one of them being W. So we know the symbolage for a line. One of our letters has to be W. And then I can pick any other letter on this particular line. So I could pick V, X, or Y. Let's use Y. It doesn't really matter which of the other 3 letters we pick. Number 2, we have to say a plane containing point X. Well, here's point X, smack dab where the 2 lines intersect. So I need the plane. Here we see we have a little notation down in the corner, P. So here we have the plane, and we have plane P. So plane P, or we could just use the parallelogram or with the P inside it as well. And then we also need a line containing point T. So T is over here. Just like up above, we have the symbolage for line, line T. And then I need one other point on this line. The only other letter they gave us is X. So line TX. Number line, find the measurements. So up above we learned that distance is basically from one point to the other, so TW. So I need to go from T to W, and I just count how many lines. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So distance of TW is 9 units. Distance of S to V, so here's S to V, 1, 2, 3, 4, 5, 6, 7, 8 units. And then we have ST plus VW. So ST and then VW. So I need to add them together. So S to T is 1, 2, 3 units. And then V to W is 1, 2, 3, 4 units. 3 plus 4 gives me 7 units. Pretty straightforward finding distance between points on a number line. Here we have the actual construction of a line segment. So constructing objects, shapes, we have to use a compass and a ruler. So here in this program, Smart Notebook, we have measurement tools. Fortunately, one of them is a compass. It's the fancy thing here that you can open up. So if I open it up, see we have a nice little endpoint. We got the pencil part, and We can move it around. We can open it up as far as we need to be. So what I need to do is construct a line segment equal in length to segment MN. I could get a ruler out, measure it, and then start from one to the other, but that's actually a little involved. And you got to be exact, and you could make a slight error. Using a compass and a ruler is going to be much more accurate. So first thing that we have to do, if we want to construct a line segment, we know it's straight. So what I want to do is use the ruler part, use a ruler, and I'm just going to draw a straight line out. I know I have I know we have endpoints N and M. So I know this end right here is going to be the copy of N. With the compass part, what I want to do is I want to put the non-pencil side on one of our endpoints, and I want to open the compass up so that my pencil, in this case, is on the other point, point M. And I'm just going to make a slight mark to make sure I'm going through. So I'm going through the point there. And what I want to do is I'm just going to leave it open like this, and I'm going to drag the compass down so that way there my non-pencil side is on one endpoint, and I'm just going to rotate the compass so that I can mark through the line. Now where that little mark is where point M is going to be. So I have now constructed a line segment equal in length to our original MN. So from N to M here that I just made is going to be the same as the N to M there. Now here what I want to do is construct a segment twice the length of M to N. So I'm going to do the same thing. I need to use the compass. I'll put it off to the side. And again, to construct the segment, first thing, I'm going to just use the ruler and draw a pretty large line, because we don't know exactly where twice the length of MN is. Now I'm going to grab the compass, and again, I'm going to put one side on point N. So in this case, the non-pencil side will be on point N. And I'm going to open up the compass so that the pencil part can be on point M, and I just want to mark it. I'm going through point M, so I'm good. I'm just going to drag the compass down. And again, here we have point N. There's our end point of N. I'm going to stick the non-pencil part of the compass on point N. And once I'm satisfied with where I want to be, I'm just going to mark through the line. Now that is once. Here we need twice. So if that's once, I got to do it once more. So I drag the compass again to where we intersect. And I make a mark, a second mark. So from point N all the way over to here, now there's our new M. That is twice the length of M to N. Now what we need to do is draw and label a figure for each relationship here. We have lines A, B, and CD intersecting at E at these specific points on a coordinate plane. Point F is coplanar, but not collinear. So here we have this nice little graph that we're going to be dealing with. So again, these points are in x comma y fashion. So first number in our parentheses here will be the x value. Second number is the y value. X axis is always left and right. Y axis is always up and down. So point A is at negative 2, 4. So I go left 2 and up 1, 2, 3, 4. B is at 0, negative 2. C is at negative 3, 0. And D is at 3, 3. So these are lines, so that means I have to connect AB with a line. Arrows at the end. And then I have to connect CD with a line as well. They intersect at point E, so there's my intersection, so that's going to be point E. And then F is coplanar, but not collinear. So as long as it's not on these lines, I can put point F anywhere I so desire. I could put it up in the top left, the top right, somewhere in the bottom left, or over here kind of towards bottom right. It really doesn't matter as long as it's not on these two lines. So I'm going to stick it right there. So there's point F. Now we have done everything. So we've drawn lines A and B, AB and CD. We've got the intersection at point E. We've plotted all the points. We've put point F. Therefore, we have satisfied every direction within our first problem. Now, number 2 says we have to draw line QR intersecting plane T at point S. So we got a few things going on. We got a line, we got a plane, we got a point. My suggestion is draw the biggest item first. So a line, a plane, or a point. Which one is the biggest? A plane is always going to be the biggest item. So I can draw a plane. A plane, again, is any figure you so desire. Again, any shape. Could be circle, could be triangle, square, parallelogram. I'm used to drawing the parallelograms. So here we have plane T. And we need line QR intersecting this. So here we have a line. And again, it's a line. It could go anywhere. It could go in any direction, any steepness, any shallowness as you so desire. So if I have line QR, I could do that. Line QR. So again, QR means points Q and point R are somewhere on this line. So Q and then R. So I drew that. And it intersects the plane at point S. So here we have 2 points of intersection. So that means I can either put point S here on the left-hand side of the plane, or I could put point S up here on the top part of the plane. We'll go down the line, Q, R, and we'll say that is point S. And now we have line P lying in plane N and containing point L. So again, line, plane, and point. Start with the biggest item, plane N. So here's my plane N. Now line P lies within it. So we're not going out. We're going to be inside. So arrows both directions, line P. So line P lies in the plane and contains point L. So that means the point is directly on the line. So I can pick any spot on the line and put point L. So there is figures of lines, planes, and points, as well as how to construct a line segment and double the line segment using compass and ruler.